What if the most extraordinary laws of nature didn't exist in the universe's most distant galaxies? But right here, hidden inside the matter that makes up your phone, your body, and even the air you breathe? Welcome to Condensed Matter Physics, the study of how billions of particles, when combined, create new states of matter and new laws of physics that no single particle could ever produce. And welcome to the Learning Studio. In today's episode from our physics playlist, we'll explore one of the most fascinating and practical branches of modern science, the one that explains how complexity gives birth to order, and how nature's collective behavior is the key to technology's future. You can watch the entire physics playlist by clicking the link below in the description. This topic belongs to our section Matter, Materials, and the Rise of Technology, where we discover how the hidden patterns of matter lead to innovation, computation, and understanding the world itself. The physics of the everyday, and the extraordinary. At its heart, condensed matter physics studies how matter behaves when an enormous number of particles, atoms, electrons, or molecules, interact with one another. It's the science of solids, liquids, and everything in between, from crystals and magnets to superconductors and quantum materials. It may sound ordinary, but condensed matter physics is extraordinary precisely because it explains the familiar, and reveals the unseen. It answers questions like, why does metal conduct electricity while glass doesn't? How do magnets align billions of atomic spins to create a unified field? Why can certain materials flow with no resistance, or trap magnetic fields in midair? In studying these questions, physicists discovered something remarkable. When many particles come together, new behaviors emerge that can't be predicted from their individual parts. This is the concept of emergence, the idea that the whole is more than the sum of its parts. Emergent phenomena, when nature creates its own rules. Emergence is one of the most profound ideas in modern physics. It's what happens when countless simple interactions combine to produce new, collective behaviors. Take superconductivity, where billions of electrons pair up and move as one, creating perfect electrical flow. Or superfluidity, where atoms move without friction, forming a liquid that can climb walls. Or magnetism, where individual atomic spins align to form large-scale fields. In each case, nature self-organizes into a new state with its own laws, something that couldn't be understood by looking at a single atom alone. Condensed matter physicists often say, more is different. And it truly is. From crystals to quantum computers, emergence explains how simplicity gives rise to complexity, and how the microscopic world gives birth to macroscopic wonders. The toolkit of modern physics. Condensed matter physics blends every area of science we've explored so far: quantum mechanics, thermodynamics, electromagnetism, and even statistical physics. It provides the mathematical and conceptual framework that underpins materials science, electronics, nanotechnology, and quantum computing. For example, by studying how electrons move through solids, scientists developed the semiconductor theory, which led to transistors, microchips, and modern computing. Exploring quantum phases of matter has led to discoveries like topological insulators and spin liquids, exotic states that could redefine how we store and process information. These insights have practical applications everywhere. AI hardware that operates at the quantum level. New materials for ultra-efficient batteries. Superconducting circuits that serve as qubits in quantum computers. And metamaterials that can bend light or sound in impossible ways. Every breakthrough in technology today, from microelectronics to quantum sensors, owes something to condensed matter physics. AI and the physics of complexity. As systems grow more complex, even the most powerful equations can't describe every interaction directly. That's why AI and machine learning are now essential tools in condensed matter research. AI can sift through massive datasets from experiments, simulate quantum interactions, and even predict new materials with desired properties. It acts like a digital physicist, recognizing hidden patterns that humans might miss. This marriage of physics and computation is leading us to a new era where discovery itself becomes automated, where algorithms can suggest new superconductors, predict emergent phases, and accelerate experimental breakthroughs. It's not just the study of complexity, it's complexity creating knowledge. Why condensed matter physics matters. From the physics of simple crystals to the behavior of quantum materials, condensed matter connects every level of nature, from the smallest quantum scale to the devices in our hands. It's the science that explains why the world works, and also how to make it better. In the coming decades, as humanity seeks sustainable energy, faster computation, and deeper understanding of matter, condensed matter physics will stand at the center, the bridge between pure science and practical revolution. This is the Learning Studio, and this was our episode on condensed matter physics and emergent phenomena. If you enjoyed exploring how matter organizes itself into astonishing states of order and complexity, make sure to subscribe, like, and check out our physics playlist linked below. In our next episode, we'll move from the physics of materials to the physics of life itself, biophysics and complex systems, where the laws of nature meet the mystery of living matter. Because in physics, even in the most ordinary piece of matter, the universe is quietly writing extraordinary stories.